so much. So when I was first asked to give this talk on truth and reality, I thought, perfect. As a scientist, I've devoted my professional career to the pursuit of truth. And like my predecessors and my contemporaries, I believe that we can uncover the truth about the real world using methods that are systematic and objective. These methods, commonly referred to as the scientific method, ensures that we can measure truth in order to get to the ground truth. And really there's a few steps along in this path, which I'll just kind of briefly describe. And so the first step in this method is to ask a question. And in these times, what we are commonly asking ourselves is, how is the pandemic affecting us in our daily lives? Right? And then the second step then is we would make some observations. So maybe we notice that people around us are having trouble eating or sleeping or focusing. They may start drinking alcohol more often or taking in recreational drugs more often. And since these are symptoms that we typically associate with stress, maybe you can formulate a hypothesis that suggests that perhaps stress is affecting some kind of brain function, right? And what is critical is the next step is now you need to design experiments that test your hypothesis. And you will get some data out of it, and then you'll analyze the data, and perhaps you need to refine your hypothesis a little bit. Maybe it doesn't quite match what you initially thought. And then you can go back and redesign your experiments and test the hypothesis again. And then you can go through this step of testing and refining many steps until finally you can make a conclusion. And so in this example, perhaps you'll find something that is consistent with predictions that people have made in studies that look at chronic stress. And what you notice is that some regions of the brain tend to reduce their activity while other regions increase. But what does that mean in terms of our behavior and our daily lives? And it's actually not an easy question to answer, because the brain is the control center for all our thoughts and behaviors. And the way it works is it takes in information of the world from our sensory organs. And here are just 5 examples, right? So we have touch, we have sight, we have smell, hearing, taste. And it takes in all this information amongst other sensory information that we have, and it constructs what the world is, this image of the world in our brain. And then it influences our behaviors. Right, so take this example of a cazuela de ave, one of my favorite dishes in Chile. And if you look at the image, you may recognize it as cazuela de ave, right? And perhaps there's a certain smell, a certain feel of the food in your mouth, certain taste that you also link to this dish that we identify as cazuela de ave. But what happens if we start taking out information? So if maybe I kind of cover the image a little bit, and maybe some of us then don't recognize that as cazuela de ave anymore, right? So this is a key question in perceptual research is what happens to our perception of the world when there is incomplete information? What do we do? So this, many of you might recognize this photo. It was quite a sensation on the internet several years ago. And that was because there were seemingly equal numbers of people who were adamantly sure that this dress was blue and black as it is white and gold, right? And so in actuality, it was later revealed that this dress was actually blue and black, okay? But the problem came about because this photo was of poor quality, right? It was taken with a phone camera several years back. It was posted on Facebook. And it turned out when we have images that are missing information, we don't all come to the same conclusion, right? And this is even true for a simple perception of color, right? So the brain can be fooled. Some people were not, right? Some people actually did correctly say blue and black, but there was a huge population that also said it was white and gold, right? And this is just dealing with one sense, right? So as I said before, we're actually constructing an image of the world with information from multiple senses. So what happens when your senses are mismatched, coming from, let's say, our visual field and from our hearing? Okay, and here I'm going to describe what is called the McGurk Effect. It's named after one of the two people that initially reported this phenomenon. First, I'm just going to show you two video clips, and then I'll explain what is the effect. Okay, and then I'm going to play a second one. Okay, and so what people commonly report for the first situation is hearing ba, ba, ba. Okay, and in the second situation, they commonly report va, va, va. Okay, but in actuality, in both video clips, the same audio clip was being played. Okay, and then here I will play
ba,
the audio.
Ba, ba.
Okay, and so this is an example of how information that's mismatched, right? So you have an image on one hand of me saying ba with my lips closed, and on the other hand, the image is with me saying ba with my lips and my teeth touching each other. And that guided you to hearing different sounds, even though the sounds were actually the same, right? So in this case, we actually saw and believed that we heard a different sound than what was in actuality the real sound. Okay? And this, people have subsequently tried to figure out why we do this and how we do this. And they have found that this is intimately linked with language. Okay, so if you have a language that doesn't distinguish ba and va very well, which is sometimes common in Chile, you may have a bigger population of people that won't experience the McGurk effect. Okay, and another key factor is how good the visual image is. And what we found is that typically the image of the face is important. Okay, so if the listener cannot make out a face, then they also will use the auditory cue as the dominant cue. Okay. But these two illusions, if you will, perceptual illusions, there are actually many of these examples. And what we really don't know is how this happens in the brain. Why does the brain, how is it that it can be fooled, right? Why doesn't it actually accurately report what is actually happening in the physical world? We really don't know how that happens. And this is not due to a lack of trying, okay? So we actually have looked at how the brain is working using machines like this one, okay? So in this example, here's a functional magnetic resonance imaging machine, okay? And so what it enables researchers or doctors to do is to look at brain activity indirectly while the human subject or patient is doing a task. Okay, so in this example, the brain, the machine is scanning the brain, right? Either in this direction from bottom to top, or from side to side, while the human is seeing something. Okay, and then what you can see is there's a particular region in the back of the brain that lights up. Okay, and this is what we know as the visual cortex. So that's very consistent with what we think this part of the brain does, right? It becomes active when the patient sees something. Okay, and these types of imaging experiments people have performed in people who are doing the illusion tasks. And we can see certain regions go up, certain regions go down. But the problem is that these kind of images are not very precise in time or in space. So you can see about around where there is activity in the brain, but you can't really see the cells, right, that make up the brain. And it's actually pretty slow in terms of how cells actually work, right? They act very active in milliseconds, okay? And the second problem is that these experiments only let you see correlations, right? So it can tell you when the brain region is active or not active when somebody is doing something, right? It cannot tell you anything about causality. Is this brain region really doing something in visual processing, for example? It cannot tell you that. And so what we've been trying to do now for several years, and we're continuing to do this, is trying to develop ways to be able to manipulate the brain in high definition, to be able to see molecules and manipulate molecules in action. And so molecules are DNA, so genetics, proteins, receptors. So we're trying to understand how these key molecules actually affect brain and brain function. So here in this example is one taken from a mouse brain. Okay? So these experiments are not possible in humans, but we can do this in mouse models and other model organisms. And here's just an example where they've labeled pathways between different brain regions by certain colors, so we can see them, okay? We can see the connections. And then as I said before, the brain is made up of cells, just like any other tissue in the human body. And it's actually made up of different cells. They're very specialized, and they actually form very complicated networks in the brain, okay? And in addition to that, they talk to each other in these very special sites, these called synapses. They talk to each other. They're very small, and therefore we can only see these sites with very sophisticated microscopes, okay? But if we're able to manipulate the communication of these sites and to see these synapses in action, we may be able to better understand how the brain actually functions and go beyond just measuring correlations and actually be able to test causal relationships, okay? And here's an example in my lab where we're using one of these sophisticated microscopes to be able to actually activate specific synapses and look at their activity. So here, lighted up in green, that's a marker of calcium, which is a proxy for neuronal activity. Okay, and so with the final minutes, I would just like to say that these perceptual manipulations are not just tricks, right? They're not just phenomena we see, but we can actually utilize them for treatment for neurological disorders, for example. So here I show an example of an illusion called body transfer illusion. And so what basically happens is that we can be tricked into thinking that this false arm here is actually one of our arms by having synchronous visual cues with our touch cues to our actual hand, okay? So actually, if somebody tries to put a hammer on this false hand that now you believe is yours, you will actually react like it is really your hand. And such body transfer illusions are being used to treat people who have lost their limbs, for example, but they feel chronic pain, chronic severe pain that they perceive as coming from this limb that they have lost. Okay. And so last, I just want to leave you with this thought that even at the very basic level, at even a color concept, a percept, right? We don't even agree on a color, or when our sensory information is mismatched, we may not correctly construct what is really out there in the physical world. And we won't always agree, because these things actually are dependent on our experience, right? And we need to know more about how the brain is actually constructing these concepts depending on our experience, depending on previous thoughts, depending on our current situation. Okay, but all is not lost, because I think that once we know that these things can happen to ourselves and that the brain is not perfect, then we can be able to deal with things that are discrepant in the real world and our perception, and even understand why other people may disagree with us as equally strong as we believe in a fact. Okay, and with that, thank you.